Howdy. This assignment will cover graphing systems of linear equations, and we will be covering questions 1, 3, 4, 5, 10, and 12. Let's get started. Number 1, we have two equations that are linear, and we have to graph them, solve them, and then state the classification. So first off, let's find the y-intercept of our first line, which is 2. And then our slope will be -3/1. Now let's graph that. Start at your origin and go up 1, 2. And then your slope is negative, so we're going to go down 3.
Taking Eric Zuniga. Eric Zuniga, come to the front, please. Eric Zuniga.
So we're going to go down 3, 1, 2, 3, and right 1. 1, 2, 3, 1. 1, 2, 3, 1. And then the opposite way, up 3 and left 1. And then that makes your line. Now, let's go ahead and graph the second line with our y-intercept at -3 and our slope at 2/1. So start at your origin and go down 3. 1, 2, 3. And then our slope is 2/1, so up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And your line is right there. And our intersection point is right there. So that solution will be 1, -1. So that's your solution, 1, -1. And since there is only one intersection, that is called an independent system. Okay, on to number 3. Number 3, let's find our slope, our y-intercept first. That's going to be -2. And then our slope is 1/6. Our y-intercept for our second line is +2, and our slope is -1/6. Now let's graph that. Let's graph the first one. So start at your origin and go down 2, 1, 2. Put a dot. Now your slope, rise is 1, run is 6. So go up 1 and right 6. Opposite direction, down 1, left 6. And there is your line. Now let's graph your second one. Y-intercept is at +2, so from your origin, go up 2. And then your slope is negative, so we're going down 1 and right 6. And then opposite way, up 1, left 6. Now we need to find the intersection, which is way over here. So we need to find that next point. And that next point, let's go ahead and use our second line. From this point here, we'll go down 1 and right 6. 1, 2, 3, 4, 5, 6. So that point will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at 12, and then we didn't go up or down, so 12, 0 is your solution. And since there's only one solution, it's independent. Question 4. Now in question 4, I made a boo-boo. This right here needs to be a 12. This needs to be a 6. And this needs to be switched around, so 21x minus 3y equals -18. Now with 4 and 5, we need to solve for y. So let's go ahead and do that. So we have x plus 2y equals 2. And the first step we do for solving for y is move the x over. So we're going to subtract x from both sides since x is positive. Bring down your 2y. and that will be 2y equals 2 minus x. Now we need to get y by itself. So to get y by itself, we have 2 times y. Opposite of multiplication is division, so we're going to divide both sides by 2. And we will get y equals 2 divided by 2 is 1, and then minus, there's a 1 there, so minus 1 half x. Let's go ahead and graph that. So graphing that, start at your origin, and since your y-intercept is 1, go up 1. Our slope is negative, so we'll be going down 1 and then right 2. Down 1, right 2. Down 1, right 2. So then make your line. Alright, now let's go ahead and solve for our second line, which is x minus 4y equals 12. First step, to get y by itself, subtract x from both sides since x is positive. So then we'll bring down our negative 4y equals 12 minus x. Now, last step, we need to get y by itself, so we divide both sides by negative 4. That'll cancel, and we'll get y equals 12 divided by negative 4 is negative 3. Negative divided by negative is positive. And then now we have a 1 here, so that's going to be positive 1/4 x. So let's go ahead and graph that. Our y-intercept is at negative 3. So from your origin, go down 3. 1, 2, 3. Then our slope is positive, so we'll go up 1 and right 4. Up 1 and right 4. Now this intersection isn't too pretty because I messed up with the original equations, but whatever. We can still guess. This point right here is the intersection. And that x value is 1, 2, 3, 4, 5. And the y value is in between negative 1 and negative 2, which is, let's just say negative 1.5. So that is your solution. And again, one solution is independent. There's 4. Now on to 5. We have our equations aren't solved for y, so let's solve for y. So we have x minus 6y equals 6. We need to get y by itself, so get rid of x first. Subtract x from both sides. Bring down your negative 6y equals 6 minus x. And then to get y by itself, divide everything by negative 6. You'll get y equals 6 divided by negative 6 is negative 1. Negative divided by negative is positive. There's a 1 there, so it's going to be positive 1/6 x. So from your origin, go down 1. And then your slope is positive, so you'll go up 1 and right 6. Opposite way for the other side of the line. Alright, and now let's solve for your second line, which is 21x minus 3y equals negative 18. Again, first step we do, get rid of your x. So get rid of all the x's. So subtract 21x from both sides. Bring down your negative 3y equals, bring down your negative 18 and your negative 21x. And now we have a negative 3 in front of the y, so in order to get rid of that, divide everything by negative 3. So that cancels, so then you'll get y equals negative 18 divided by negative 3 is negative 6. Negative 21 divided by negative 3 is, oh crap, that's positive 6. So positive 6, negative divided by negative is positive 7x. So now graph that line. Your y-intercept is 6, so from the origin, go up 6. 1, 2, 3, 4, 5, 6. And then our slope is positive 7/1. So that means we need to go up 7 and right 1. Since we can't, do the opposite. Down 7 and left 1. That's the only point you can put on there. Now, since I messed up the original equations, that means our point isn't going to be perfect, but we can still just guesstimate that point. I'm going to go ahead and say it's going to be negative 1, negative 1. So that's our solution, negative 1, negative 1. And again, one solution, independent. Then number 10. Number 10, we're given the table and two equations. Pretty simple. The x values aren't given to you, so just make your own x values. And I'm going to choose negative 1, 0, 1, and 2. Now to get your y values, you need to plug your x values into your x's. So let's go ahead and do that. I'm going to plug this 1 into that x. So 1 plus 2 is 3. Then move on. 0. 0 plus 2 is 2. Dang it, it should be a negative. Gosh darn it. Negative 1 plus 2 is 1. And then this 1 plus 2 is 3. This 2 plus 2 is 4. And then move on to your y2. Plug these numbers into that x. So negative 1 inside the negative x. Negative is positive, so that'll be positive 1. Plug in the 0. Negative 0 is 0. Plug in the 1. Negative 1. Plug in the 2. Negative 2. Now we have our table. We're going to go ahead and graph that table. So graphing that table, first graph your first coordinate pair of negative 1, 1. So negative 1, 1. Then graph 0, 2. 0, 2. And then 1, 3. 1, 3. And then 2, 4. So there's one line. And then go ahead and graph our second pair. So negative 1, 1. Already there. 0, 0. 1, negative 1. And then 2, negative 2. And that is your second line. Okay, so we have one intersection point, and that is the solution. So this point right here is negative 1, positive 1. So put that right there. Again, one solution, independent. Now, moving on to question 12. Again, there's no x's, so put in your own x's. Negative 1, 0, 1, and 2. Plug your x's into your x values. So, starting with your first equation, plug it in. Negative is positive, so we'll have positive 1 plus 3, 4. Plug in 0. 0 plus 3, 3. Plug in 1. We'll have negative 1 plus 3, which is 2. Plug in 2. That's negative 2 plus 3 is 1. Now plug it into your second equation. Negative is positive, so positive 1 minus 2 is negative 1. 0 minus 2 is negative 2. Put in 1, that becomes negative 1 minus 2 is negative 3. Put in 2, negative 2 minus 2 is negative 4. So now we're going to graph. And so use your first coordinate pair, x and y1, which is negative 1, 4. 0, 3. 1, 2. 2, 1. And then 4, negative 1. So 1, 2, 3, 4. I know, not 4, negative 1. I'm sorry. Negative 1, negative 1. 0, negative 2. 1, negative 3. 2, negative 4. Okay, so that's the line. And those turn out to be parallel. And parallel lines are called inconsistent. And they have no solutions. Okay, that's 6 questions out of the 12. I leave the rest up to you. Thanks for watching.